Up for the methods of copying high security keys. The Lost Film Festival will take place tonight in the Pavilion movie area. That's on the second floor, so if you want to check out some films, all of the Hope conferences always tend to have some interesting flicks. Sunday from 10 a.m. to 1 p.m. you can come to the 6th floor Zurich room to take one of the FCC ham radio exams. So if you want to get your ham radio license, you can do that at this conference. Also, DVD sales of all the talks at every discussion that goes on at this conference. You can buy a DVD right out here in the vendor area on the 18th floor. Also, some people have inquired about the bizarre artworks that are hanging up at the different rooms. Those will be for sale at the end of the conference. The artists who put those together, Rob T. Firefly and Gray Frequency, did those out of the kindness of their hearts, and a couple people have inquired about purchasing them. There's, thank you. Evidently a lot of duct tape was involved with the assembling of it, but those will be for sale. So you can go to the info desk downstairs and give your name and say that you're interested in taking one of those home with you. There's a dual purpose to this as well, which means they don't have to load them onto a truck and take them back home. So you can make your best offer. Also, just a reminder, if you could set your cell phones to vibrate just so it doesn't disturb the conference. Remember, there's the Zeus room down the hall, which is the 4th track. There's a lot of really interesting discussions going on in there. Right now it's the OLPC demo, whatever that is. And at 3 o'clock is hacking digital player pianos, which I was unaware that there were still player pianos, but I guess those are called iPods now. All right. You know, what would a conference be without PowerPoint, actually? Thank you. Too close to being ready? Get one of these mics close to you.
We do. Maybe you want to have Let's see. How do I turn off network?
I don't know. Are you getting hacked? All right. Think you're ready?
Okay, I'm ready.
What's the name of the organization downstairs that has
The Lockpick Village. It's near the Lockpick Village. Yes.
All right, we're going to get started. I've known Barry Wells for several years, and he has hooked me up with a fantastic lock-picking set that's come in handy quite a few times. Also, if you follow some of the more geeky blogs, every now and then you'll see his name mentioned as he's discovered some amazing new lock-picking hack. These guys are at a lot of hacker conferences around the world and encourage you to check out some locks, some picks. They'll guide you through some of the tricks on picking those locks. And down in the lock picking village on the second floor, they've got sort of a workshop, and you can also buy some of the lock pick sets. I highly recommend them. This is Methods of Copying High Security Keys with Barry Wells and Han Fei, who is sitting down there inexplicably. All right. Give it up for Barry Wells.
That's a warm welcome. Thank you very much. Yeah, where's Han Fei? Well, there were some technical difficulties, so we decided that the first part of the presentation, I'll do it by myself. And when there's time for questions, Han will sit here next to me to maybe answer some of your technical questions that you have. But I'll entertain you. Don't worry. You know, you will not miss him that much, I hope. There's Han Fei. Okay. Autographs after the session for him. But anyway. Okay, here we go. Yeah, the thing is, as was explained earlier, I've done quite some lockpick presentations, and I decided there was time for something new. I mean, I always try to come up with a new thing to talk about in the lock area, and you can keep, you know, going with lock picking and lock bumping and all that stuff. But I thought, you know, let's do something that's, I think, not being talked about much, and that is copying keys, copying high security keys, and how easy and difficult is it to actually make copies of pieces of metal, because that's actually what a key is. So first things first, what actually is a key? We all have several keys on our keyring, but what does a key do, and how does the key operate, and why can one key operate the lock and the other key cannot, while they almost look the same? That's simple because in most mechanical locks the key push pins to a correct position, and if one of these pins is not pushed correctly, as I will get back to later, this is annoying. How do I turn this off? What's that?
Your peers are open now.
Okay, I don't, okay. Yeah, so I'm thinking of how can I disable my Wi-Fi network. Anyway, don't hack me, please. Okay. Anyway, what the key mostly does is inside the mechanical lock, it will move some elements and unlock it. If one of the elements in the lock is not in the correct place or in the correct angle, the lock is not going to operate. And yeah, that's what it does. When I'm doing the presentation, I will talk about locks in the American way, the American protocol, the way the lock is. This is for a European lock, this is not standard, because in Europe the lock is mounted upside down. But in the US the locks are mounted up. And since my first experience was with American locksmith books, you know, I always follow this protocol because this is how I grew up. So that means that we have a house, plug and a pin, and we have bottom pins that are actually in the plug, and we have house pins that are actually in the top. So if I say a top pin, I mean pins that are in the house. I hope that's clear. So if you look inside the lock, you see the blue top pin and the red bottom pin. At this moment the core cannot turn because the blue pin is in the way. Only when the key enters the lock and lifts up this red pin, only at that time the core can turn. At this moment the blue pin is in the way of the core to turn. And that's, you know, basic lockpicking, the very basic stuff. And as I said, I've been here now for many, many, many years, and there's a lockpick village downstairs with 20 people, 30 people teaching you how to pick locks, how locks work. So I guess by now everybody understands this, and if not, you know, see us downstairs and we'll explain it a little bit deeper in detail. Having said that, you know, this is one more image of a correct key in a core where you see all the pins, all the core pins on one line, and if you then remove that key a little bit, then the pins get out of alignment, and the first pin, as we say, sinks into the core, meaning that the pin on top of that will jam it. The second 2 pins will actually stick out of the core a little bit, preventing it from turning it. So now it has turned into an incorrect key. And I'm going to turn this off, even if it takes me 1 minute, because this is not nice. Yeah. Help. System preferences. What? Yeah. Babak to the rescue. This is Babak, somebody I dearly love, especially.
You want a no network, right?
I want no network, right. Piece of shit, Mac. Okay, here we go. Well, at least, you know, now we got rid of that annoying thing and I can really focus now on the presentation. What's important to know with keys and locks in the mechanical domain is that it's all fixed size. So the pins that are in a lock, the pins that are preventing the lock from turning if the incorrect key is inserted, have increments. And most of the time there are 10 steps that these pins can have. So you can have a really long pin, then it's a position 9. And if you have a really short pin, it's either 0 or 1. And these pins, you know, if you can identify the length of the pin, you know the combination of the lock. If you know that in gate number 1 is a pin 5, you know, then that is bypassed. You can cut the key to that height. This actually is a screenshot from a computerized key cutter in a locksmith shop. So if you know the combination of the key, you can just enter it and insert a blank key, and the machine will cut the key for you on code. How is this possible? Anyway, turn off growl. Okay, I think it's done by now. Okay, so having said that, you know, it's very important to realize that the depths in a key are not random. If you look at these keys, they have fixed steps, and also the spaces where the cuts are in is also a fixed length. Now, what methods did the lock industry come up with to protect people from copying keys? The most clever one is they do patented tricks in the key. So they have some patented mechanism that will do something extraordinary that they have a patent on. And in that case, you know, only they are allowed to make the blank. So it's a legal protection. It's not a technical protection, it's legal protection. Really, a locksmith, if he makes a patented key, is really in a lot of trouble because you break a patent. You're not doing something naughty. It's another thing that they do, and it's sometimes combined with patents, is adding special elements in the key that key cutters normally cannot copy. So at first, you know, we started with these dimple keys, the keys that have the holes in them. And at the beginning, you know, for locksmiths, that was really a big deal because they couldn't copy it. But then a couple of years later, there was so much demand for a machine that can do that, that they made a machine to copy dimple keys. And then they made dimples that were not fully drilled. And, you know, it's a whole war going on between the manufacturers of these machines and the lock industry. They also like to add, you know, things that are special to that lock. Sliders, magnet, cuts in an angle, floating elements. I'll get back to that all later. Another thing that they do is assign an exclusive profile. The profile is the shape of the key. So if you look at the tip of your key, you know, I've noticed that in the US it's mainly a straight line with maybe 1 or 2 small angles in it. And that's nothing unlike in Europe where, you know, a key goes zigzag from one side to the other. and really has a lot of different shapes. But I've seen that in the US, a lot of the Schley keys and the Primus keys, no, not Primus, the quick sets, it's all a straight line with maybe one or two, so that's nothing special. But what the lock industry does is they assign a special exclusive profile, an exclusive shape of the key to a specific locksmith. They say, okay, listen, we will, give you this exclusive profile. It will not be for sale for anybody else, and we will just not hand it out to anybody else. But it doesn't mean it's protected by a patent. If I want to make that key, that there's nothing legally, as far as I understand, preventing me from copying that piece of metal if that's not patented. But yet that is done often, especially to big dealers, big locksmiths that have their own profile, or to a project. If you have a school or a hospital or whatever, they will get an exclusive profile that can only be sometimes even requested only by the keys can only be made by the manufacturer. Now, these methods mentioned above will only prevent copies made at the local hardware stores or at the, the local locksmiths. Because if you're really determined, I don't know if you read the latest 2600 magazine, I wrote a small article on copying keys that are a little bit difficult to do. It was a youth experiment, so maybe you want to read it up. But if you're really determined, you can make copies of metal, pieces of metal, because that's what the key is. And Han and I have been in a lot of lockpick or locksmith, lock manufacturers, in a lot of companies. We looked at, let me think, drifting off. We visited a lot of lock factories. And if you see how keys are made, the keys are made, 1 second a key. Bish, bish. They really grind it out of pieces of metal really fast. And so if you expect as a lock company that, a thing that you can make in 1 second with your high-tech machine, somebody else can never copy, that's a wrong assumption. Because it's, at the end of the day, it's only a piece of metal. Now, the most simple way to decode a key or to copy a key is to look at the key if it has a registration number like an SH4 for Slake or whatever. If you can identify what type of blank, what type of profile is used, and it's mostly written on the key. And the next step is to just measure up the depths of the cuts. And if you know that, you can go home and you can have a file and you can have a blank key and you can cut it. Or if you have access to a computerized machine, you can cut it. And it's really nothing more than, if somebody can determine how deep a specific cut is, the game is over. If you don't have something to measure the key by and you have access to a key that you want to copy or that you're interested in high security keys, it's really funny because they have a lot of zigzag lines, especially in Europe. And as you can see on this Winkhaus key, there's a lot of lines, there's a lot of changes in the profile going from left to right. And you can actually use that to read the key. You can say, okay, the first cut is actually right in the middle of the first groove that you see. And the second cut is actually much deeper, and the third cut, etc., etc. So with these lines, you can more or less identify roughly, even if you don't have access to something to measure it, what the combination is. And a skilled lockpicker, especially people from Tool and in Germany, if they have a peek at your key for 1 second, it's lost. They know high, low, high, low. Okay, that's it, And they know what to expect, and that really is intelligence. Then your system is compromised. If people with some knowledge look at your keys, then... Now, another way to make copies of keys, if you cannot take them with you, is to make a detailed photo. I mean, photo cameras getting smaller and smaller, or a Xerox copy. And Xerox copying really works well. It's an almost one-on-one copy. You can go home and measure it and have a look on where on the lines the cuts are. And as you can see here on the Winkhaus lock, this is just a standard photocopy. Just the first run, I just made a photocopy. And as you can see, once you photocopy this key, you can spend 3 months, figuring out how to make a piece of metal that will fit the lock and how to cut it exactly to that depth. But at the end of the day, if people have access to a mechanical key for a very short time, the whole system can be compromised. Another method that I heard of, if you don't have access to a Xerox machine and you really are focused on getting a copy of that key, is to impress it into your arm for as long as you can, and just give it a try. I mean, don't do it for 30 seconds, but just do it a little bit longer, and just see how long it takes for the imprint to vanish. It really stays on quite some time. Having said that, this even gave me some bruises afterwards. But afterwards you can identify more or less how deep they are, and even if you have to guess a little, it's still interesting, way to do it. Now, if an exclusive profile is used in a key system, you have a problem going to get the original key to make your key from. And it's so funny that over the last days I've spoken with some people. One was a 17-year-old engineer that said, "Oh, that's funny that you say that, because when I was at high school, I wanted to have a copy of the master key, not to do anything illegal, but just to explore a little and to make my life more comfortable." And he said, what I did was I called the janitor that my key was inside and that my door was locked, and he came with the master key, and I took a peek on the master key and saw in what positions it was different from my key. I thought, wow, that's amazing. And then he recognized more or less where the cuts were that were different, and then he removed his lock from the door and looked at the pins and laid them out. He just took his own lock out of the door, looked at the pins and said, okay, on these 2 positions, my key is too deep. The key that he had, couldn't be turned into a master key because they were too deep. So what he did was he used a soldering iron, filled up the keys with solder, and he had this core and he could file until it was a perfect fit. And he had a master key to the system. And he gave me the master key. He was kind enough to give it to me, and I don't know if I can put it under here. But let's just go with the presentation, and we'll see later if I show them. But that was really funny, and that's not the first time I heard that people actually fill up existing keys with pieces of metal to create a blank that way. And the key that you see here is an ASA Twin, which is a very high security, very accurate lock. And Han and I once had a bet with somebody that he said, you cannot copy this key. And what we did was we bought a key at the same shop where he bought it, and they all have the same sidebar code, which is the most difficult thing. And we filed the positions that his key had up. And what I actually used is I used pieces of a nickel to cut V-shaped pieces and solder them in with hard solder. So I used a little bit different technique. But at the end of the day, if you can get access to any key that will fit that lock, if you have time enough and if you're determined enough, the mechanical system will lose after all. It will. Now, there's a little story from the Netherlands. I think about 15 years ago, 20 years ago, there were phone freaks in the Netherlands that that had access for a very short time to the key that you see above, the lock that you see above, in the green. Our national phone company is green, the color. And what they had actually was an icon lock, and the icon lock is not only just your straight key, or even if it's a zigzag key, but they have little wings on the side. I don't know if you can see the wings on the side of these both these. And what it is that on the side there's actually elements, wings, that push away locking elements in the side of the key. So there's a row of pins on top, and there's a couple of pins on the side, and they all have to match. Now, they could not get a copy of the key that goes in, even if it's too low, so they had a problem. And they wanted to have a copy of that. So one of their friends was a mechanical engineer, and he said, "Oh, no problem, I'll make that key for you. It's just a piece of metal." And that's what he did. This is the picture. He measured the key in 3D, and he put all the measurements in his equipment, and out came this key. I don't know if you can see it, but this is not the original key, because I never had access to that. It's a similar key that has the wings, so if you can see it. And this is the copy that they made. And yeah, when I first saw that, I said, I gotta have a copy of that key, and not because I wanted access to that phone booth, but because I thought it was such a great idea that somebody was actually skilled enough to just take a blank piece of metal and set his machines and do some magic, and then make a blank key. And I found that really amazing. And even for me, that was an eye-opener that somebody actually did that. I mean, that you can do it in theory, yes, but that people actually do that, that's amazing to me. Now, these were all the simple methods to hack around a little bit with keys, and but sometimes you have access for a very short time, and one of the things that you can use to make quick copies that are highly accurate is with clay. It's a very simple idea. I think we all, as a kid, played with clay and put something in and saw the impression. And that's basically what this kit does. This is a kit from a US toolmakers organization for locksmiths. And it's, I don't know what I paid, I think 150, 200 euros, something like that. And it's even overpriced if you look at what's inside. Well, it's a very simple set, but it's really very accurate. So what's inside is some baby powder, as you can see, and I'll get back to that later. The two white things there are little clamps. That's also why this kit is called the clamp. And that's actually what we will use to make the impression of the key. There's some clay inside, there's some low melting metal inside, there's a candle inside, and basically that's it. I think you can more or less imagine how it works. I had the idea to, be really daring and use this this video stand to do it step by step, but I decided not to do it because technique is not my best friend these days. So I decided to just make more or less a sort of a photo thing on how this works. So if you want to make a copy with this clamp kit, step one is to take one of these clamps and open it, get some of the clay, mold it, just mix it a bit, and have your key ready. Then you separate the clay and you fill out the two halves of the clamp. It's really straightforward and really simple. And then with the, I don't know how you call that, but then you separate the top remaining layer with that knife or with that sharp edge. And you do that on both sides. And what you then do is, if you would now close the clamp, both sides would stick together. So it would not be possible to remove them easily. And that's where the baby powder comes in. You apply a generous amount of baby powder on both halves. On one half I already smeared it out, on one half it's there. By the way, I flew in with this stuff through customs, and I was like, from Amsterdam with a bottle of baby powder and plastics and clay, and but it worked out, they let me in, and I'm always surprised if they let me in, but anyway, you can see where this is going. Then what you do is you gently press the key into one of the halves. You don't want to push it in too deep. You just want to push it in to the point that it doesn't fall out. So you have to make it stick a little bit. That's what you do. Now, then, you know, I can make 10 steps in closing it, but this is, yeah. You close the clamp, and you really press tightly. Now, if you then open it again and gently remove it, you can see, and I don't know how good this beamer is, but here on the screen, you know, it's really, really, really accurate, the impression that is left in this silly clay. And it's nothing special. I mean, it's probably something that any kid can make for a couple of bucks. But that's what you do. Now, what you do afterwards is you close the clamp, you heat up some of the metal, you pour it in. While it goes in, you tap it a little bit so the air bubbles come out, and then you will have your key. I mean, I could have made all these steps as well, but then, you know, my 2 hours would be up by now. So I decided to let you have something left for your imagination. So we tried this on a wide number of keys, especially since we came here. Han, who has a huge collection of locks, picked up some of his most high security locks from Europe, from the US, and that worked in almost all cases. In almost all cases, we were able to make impressions of these pieces of metal, pour some low melting metal into the impressions, and have a working key. Sometimes it required a little scraping off edges, you know, sometimes it's not perfect. But especially if you scrape off some metal and you have an eye on where to scrape off the metal, you know, you will definitely be able to make it. But in some cases, it just works straight out of the box, nothing fancy. So this is an easy way to copy keys, even the high security ones, as you can see now. Some people have been bashing on Medeco all conference, so I thought, you know, we might as well include them. No, but I think Medeco actually makes very good locks, and it's, yeah, almost a pity that these guys are in that corner that they are in now. Having said that, you know, the things are as they are, and in high security applications, they have a serious problem as far as I'm concerned. The Medeco lock that you see, or the key, has got angles in a cut. That's the thing with Medeco. They don't only lift pins to a position, they also rotate them in a position. And we were real curious if, you know, with a simple clay impression kit, if these angles would be correct. And it worked. We did have to modify it a little bit at position 5. The metal was not perfect there, so, you know, to be honest, it didn't work out of the box straight away, but with a little modification it worked. And I'm quite confident that, you know, if you try it more, or if you get a little bit even more experienced with using this, that you'll have a fairly good chance of making an impression and making a working key this way. Now, another key that we copied is the Schlage primers. And Schlage primers is really top of the line at the moment, I think, in the US. It's one of the most difficult to manipulate lock. And also the key copying, you know, they're very proud of, Han showed me a brochure saying, often imitated, never duplicated. And they are right. It's a very, very, very high tolerance lock. So if something isn't right, the lock is not going to open. The sidebar profile that you see over there actually picks up a pin, puts it to a specific height and to a specific rotation. These are called the finger pins, and you can see them here, hopefully. And it's really an ingenious system on locking and unlocking, and it's one of the top line. And Han wrote an article about it. It still has to come out, I see. More information on ASA Twin Systems Part 2, and I think you're now only at Part 1, right?
Yeah, I need to tell some information about Part 1.
It's okay, it's okay. Well, yeah. Later, you know, if there's time left, Han can answer some of the questions or talk something about it. Now, the funny thing is that we managed to make a copy of this Slake Primus key, and as you can see, you know, it looks the same. But what was really funny is that there were actually holes in the key where these angled cuts are at the bottom of the key. But still, the key worked out of the box without any modification. You know, it worked, and we're really surprised by that. But sometimes, if the metal in the key is getting very thin, the liquid metal that you're pouring in cannot fall in all the way, or doesn't get in all the way. And even while tapping it, sometimes the metal is not there. But in these cases, still the key works. Now, one of my personal favorite locks is the EVA 3KS. It's a lock that's mostly unknown, I think, to people in the US. But it's like a watch almost. It's really high precision. It works with sliders, so there's no pins, but there's sliders that have to be elevated to a specific height. There's multiple tracks, as you can see, in the key. 3KS stands for Dreikurvensysteem, which means in German 3 curves system. Actually, they're only using two really variables. But it's a very sophisticated key, and I was really curious if we could do it with the simple clay impressioning kit, if we could make a copy of that. And we also succeeded in making a copy of that. Now, as you can see, the same thing happened as with the Primus, and that's that there's actually a hole in the key. Can you see that at the tip of the key? There's a hole. Can you all see that? And actually, there's a few more. I think also over. And anyway, we tried it, and also this key also opened the lock, because at the end of the day, these sliders have to be pushed in a specific position, and it doesn't matter if there's no metal there, as long as these sliders are being pushed in the correct position. And the distance in the middle of the key is really, really close, so it's actually quite logical that some of the places are that there's no metal there. But the bottom line is that if you go to a lock shop and you say, I want a copy of this key, they will look at you really funny. They say, it's not a blank that I have, it's not even a system I know. And even if I know the system, how am I going to make these grooves with different depths? It's a really complex system. Yet, with this kit of only 150 euros or 200 euros, what did I pay? You can make a copy of this key relatively simple and straightforward. Having said that, the question is, how many times can you use that key? We tried it a couple of times, and after opening a couple of times, it already started to wear a little bit, because these locks are really high security locks. Now, the application with this clay kit is that you can open the lock a couple of times, and the basic idea is that you make a copy on a key machine later. So it's just to preserve the cuts in a key, and for you to bring it to a normal copier and being able to cut it. So if you have evil intent and you have access to a really interesting key, and you want to open once or twice the lock to steal stuff, for that it's going to work. But if you're going to use it on a daily basis, and you have to open the door multiple times a day, yeah, good luck. It's not really going to last that long, I think. Now, we started with the Abloy ProTech. It's one of Hans' favorite locks. And we also tried it with the clay kit, and it came out just fine. But we also tried it with another technique that we use to make copies of high security keys, because we could not copy all the keys, not all the high security keys. And I'll get back to why it didn't work. But this is actually a copy made of an Abloy ProTech key, a system that works with disks, as you could just have seen. But this copy is not made with clay. This copy is made with silicone. And that's actually something that's used in the dental industry. Now, I told you about my clay kit that was maybe 200 euros. There's also a kit with silicone impressioning, silicone based, and that kit is much more expensive. What you see here, I paid 500 euros for, and it was still considered a bargain. This can make me approximately, I think, what was it? 35 copies. 35 keys I can make with this kit. So it's not cheap, but it's very, very, very accurate. And as I said, it's based on technology from the dentist area. And what you have is the blue stuff on top, and that really is a big pot. And that actually is a silicone liquid. And these other two bottles that you see here are elements that you have to mix with that silicone to make it harden. So the silicone from the thing you can just pour, just as if it is, well, it's not like water, but it's almost like that. But if you mix these two other elements with it, within 10 minutes it will harden out. So the whole idea is to make the silicone on the spot, to mix it, and then use this, which is actually the heart of the system. It's a really heavy-duty, high-precision clamp, and this clamp is used to clamp the key while you poured in the mixed silicone material. So you first, you fixate the key to the top part, and then you put the two clamps together. You mix the material, you pour it in, and then with the leftovers, you paint the key a little bit. You make sure that there's no air bubbles in there. So if you have this blue goo, you really apply it as well as you can to that key, and then you stick it in and let it wait for 10 minutes. And if you then remove the clamp after 10 minutes, there's this hard piece of silicone, rubber actually, that's what it is. It feels like rubber. And it's not stiff, it's flexible, yet it is extremely exact. The only problem is that your key is still inside, and how are you going to get that out? As I said, after 10 minutes of waiting, you can open it, and with a knife, and that's why the steel shape is so important. You cut away, you make an incision into this silicone part, and you can remove the key. Now, if you cut precisely, it will work out just fine, and you can make really, really, really excellent copies of high security keys with it. And it can even do some keys that you cannot do with clay. For instance, since we came to the US, we wanted some high security locks. One of the high security locks is a Sargent Queso lock. And with the Sargent Queso lock, there's pins coming from 3 sides. Pins from the left, from the right, and from the top. You can see over there on the left that is the case. That's what the key looks like. And it's also a high precision lock. The slightest error will not open the lock anymore. We tried it with clay, and the interesting thing with clay is that if you make a copy with clay, it will work fine, except for the side pins. The pins that are on the side here. So it's not the pins on the top, it's not the pins on the bottom, but on the side. As soon as you remove the clamp, if you open the clamp, you will destroy your impressions from the side. And with the silicone-based material, you gently cut at the edges, and it will work out just fine because it's flexible. We managed to make a copy. It works fine, and yeah, it shows that with the silicone thing you can do keys that cannot be done in a different way. Han and I visited Vienna a couple of weeks ago, maybe months. Time flies. And there's a company called Kaba, and if you talk about locks made like a watch, you know, these locks are made like a watch. It's so exact, so precise. It's really, really, really one of the most high tolerance locks that I know. They have more than one pin in there. They have sometimes up to 22 positions where pins are from 4 angles. And the pins are really small and really pointy. And if you try to pick it, you know, we of course try to pick it. If you put tension on it and you start raking in and out, the lock will all of a sudden start to run less smooth. It's very easy to disturb the lock if you damage it, or you know, if you do these kind of things. But it's very difficult to pick it. It's very difficult to manipulate it. And it actually was the reason that I bought this silicone impressioning kit, because you know, we were going to that factory and I just wanted to have something that I could break their locks one way or the other. So yeah, that's what I did. But I was really annoyed that I couldn't make this key with my clay kit, because what happens, and you can clearly see it here at the bottom. I'll point it out for you. As you can see on the previous screen, that the pins on a Kaba are cut on a 45-degree angle, meaning that if I put it in a clamp and I remove it, just as with the queso, but then much more severe, I will distort the gaps. And especially since it's such a high security, high tolerance lock, I couldn't get it to work, and it really frustrated me. And I really tried, you know, with different angles with the clay kit, but it didn't work. But with the silicone kit, it worked, and they weren't happy. But yeah, you know, that's life. No, but seriously, I mean, you know, it's the top of the line of European high security locks, and you know, they should be able to take that. So. That more or less covers the thing that I did with our own little research on high security locks copying. There is a difference that I want to point out between clay and silicone. The clay kit, if you prepare the clay and you prepare your clamp and you somehow manage to put it in your pocket, you can make an impression of any key that you can get your hands on in 10 seconds. You know, you put it in, you squeeze it, you take it out gently, you stick it into your pocket carefully, and you know, off you go, and you made your copy. The disadvantage of that kit is that it's not as accurate as with the silicone-based stuff, but it's still very accurate, and I managed to copy almost every key I tried with that. So as long as there's no 45-degree cuts in it, or grooves that are in a specific 45-degree angle, if it's flat key, then most of the time clay is good enough. Now the advantage of silicone is that it makes very high precision copies if you use it right, but it's slow. It takes you 10 minutes to dry, to let it dry. You have to mix it on the spot. You cannot, you know, have pre-mixed, so you have to mix it. You have your all small little chemistry factory with you. So these are the two differences in the system. Now, the locksmiths also have a new toy that, or new, they have a toy that they use for copying high security keys, and it's called an easy entry machine. And the easy entry machine is really a nice device. It's a really great invention. What it does is it scans the the upper side of the key that is never cut, because the cut always starts off a little bit away from the shoulder. And it scans that part of the key with a very thin feeler. And then you insert the blank that has no cuts in it at all with the smiling face. And then the machine starts making the cuts like it scanned. And you know, after a couple of minutes, you have a blank key to that lock. And the nice thing about this machine is that even for intelligence agencies and entering teams, they have a special module that if you have a picture of a keyway, they have this small Photoshop-like image where they can just draw the line of that profile, and they will cut the key, even if they don't have access to the original blank or the original key. So that's really a very nice way. Unfortunately, it's a little bit above my budget. So if people here are into, you know, milling machines and computerized milling, you know, I'd like to have a talk with you, because maybe we can do this thing open source and just, I would really like that, to have at the end of mechanical protected keys that, yeah, enough is enough. Now, this is actually where Han comes in. Where's Han? Well, anyway, yeah, if you want, you can say something about. Sure.
Okay, just for a short moment then. These are. Oh. These are some locks out of my collection, and these are keys which are impossible to copy with the silicon or with the clay kit. Reason why they are impossible to copy is the fact that they have movable elements or that they have magnets in them. And you can see, for example, the multi-lock left above. Everybody knows that. There is an interactive element in it, and some part in the lock must be lifted up to release a certain pin to let the plug rotate. Another trick we see is, for example, is for example the EFA MCS. That's a cylinder with 4 magnets in it. Then we have 8 magnets in it. Then we have the Bricard number 1, which has a floating element in it in the top. Then we have the FTH, which have a floating or a springed element in the tip of the key. Can you point it, Barry? Here, number 3. No, below. That one, and then the tip. You see that tip? That tip is springed. And therefore, that key cannot be copied by molding. We have here the bilock, also known, I think, by a lot of Americans. Below there is an element which rotates or makes a 90-degree rotation to push something in the lock. And then we have the Motura, which here the number 1, which have a magnet in it. And the most curious thing, the most curious key I found in my collection was the number 5, and these were the zipper locks. Zipper locks. So it's the same thing you close your pants with. And as you can see here, it's a key which exists of loose elements, just like a zipper, flexible elements which go into the lock and which go into a labyrinth in the lock, and then it moves that way like a fish, and then it sets the pins. So it's a very extreme and strange lock. It's a manufacturer which does not exist anymore because the locks were too expensive. I don't know if you have more sheets for me, buddy. Okay, then I can go.
Okay, so, can you hear me? No? Okay, it does work. Yeah, so these are some keys that we couldn't copy with this technique. Having said that, and I stand with that, no matter what you make mechanically, if you have a mechanical key and I'm determined to make a copy, I'll copy it. It's just a matter of time. All these keys are made in the factory in a couple of seconds, and then you have a lifetime to spend on finding a way to make a copy. So they cannot win that game. They can make it as most difficult as they can. And I think that, for instance, the number 5, the EVA one with the magnets, that's really one of the most difficult ones. You should look it up on the internet to know exactly why, because it's a long story. But it's a really secure lock, and so are most of these that are here. Okay, now people that know me know that I do a lot of lock picking, and the part that we just had, it's exactly 1 hour, was about high security locks and making copies of it. So that was part 1. Another thing I want to tell you what I've been up to in regards to locks is impressioning, and it's with everything that I do. It's a lock opening technique called impressioning, and the last thing I did for the last 2 years is impressioning. Just as with the 3 O's of tool, you have to practice over and over and over again. I've been practicing a lot. So what is impressioning? Impressioning requires that you have a blank, you have a file, you have some patience and some skills. I brought with me a book from my good friend Oliver Diedrichsen, who interested me in this 2 years ago. He finished his book. I went over, I looked at it, he explained me how it worked, and that was also the first day that I opened a lock with impressioning. And the nice thing about impressioning is that at the end you will have a key. So once you have bypassed the lock with impressioning, you will have a working key. And it's very useful for locksmiths and non-destructive entry teams, so government teams that are allowed to search your house or place stuff in your house or whatever. They're allowed to open your locks. And I've learned that this is actually a method that's in use up to this day, because it's such a powerful technique to open locks secretly. It's not like lockpicking, that you can just more or less start and then you manage to open some locks. It requires quite some skill and practice, and but the upside is that if you succeed, you have a working key, and so you only are challenging the lock once, and if you win, you have won forever. While with lockpicking, if you open a lock, it's great, you can close it, and then you have to go all over again. It's silent, and it's possible to come back later. You can, work on impressioning on a lock for a few minutes and then go away, and then the next day do it a couple of more minutes. And for non-destructive entry teams, that is an appealing thing, that if you try to pick a lock, if you go back, the lock is reset. So what is impressioning? Now, this slide is from a different presentation, so remember the binding pin doesn't make much sense because I didn't talk about lockpicking yet. But what happens is that if you have a lock and in this position you want to turn it to the right, the lock is not going to open because the blue pin is in the way, right? The blue pin is preventing the lock from turning. And that's actually what we're going to use in impressioning. There's a few very simple tools that you need in order for a successful impressioning attempt to do it. You have a file, that's very important. You have some good light, some clamps. I'll explain. What's very important with impressioning is that you have a blank key and that you have a clamp to hold that blank key. And what you will do is you will insert the blank into the clamp, and if you stick it into the lock, nothing will happen except that all the pins are raised as high as you can. This is a standard blank key, and if you look on the top of the blank key, you see it's shining. It's got this silver colored chrome, nickel chrome no chrome, layer on top. And with impressioning, it's important that we brush that off. So with a very fine file, I make the surface one smooth path of, so I remove the hard silver layer and get to the brass underneath and make it one smooth line of brass. What I'll then do is I insert a blank into the lock. I'll turn it to the right, and by turning it to the right, 1 or 2 pins will be jamming the lock from opening. As we know with lockpicking, if you turn to the right, it's not all the pins that bind, it's always 1 or 2, maybe 3 pins that bind. So you turn it in, you turn it to the right, pins say, okay, I'm stopping you from turning. Now, with impressioning, you start rocking your key up and down a little bit. Now, it's in the lock, it's in the keyway, so there's not a whole lot of play. There's only a very minimal movement that you can make. However, the pins are jammed between the house and the core, and if I try to make a movement, something has got to move. So it's either the key that's got to move or it's the pin that's got to move. Well, I use a little bit more force, so I will actually lift the pins up just a fraction of a millimeter. It's very little. However, that will make a dent in the metal. And that will tell me later, hey, this is where a pin is jamming. Here comes in, after this round of, inserting the key, turning it to the left, making a few up and down movements, turning it to the right, making a few up and down movements, because if you turn the key to the right, there's other pins binding than if you turn it to the left, because that's the way with the imperfect locks, how they all work. That's what I've been talking about for years now, that these mechanical tolerances is why these locks can be picked. So if I apply torque to the left, I get other marks than if I apply torque to the right. And if I look at my blank key under this little magnifier with indirect lighting I have, or I use it under TL, is that what it's called in the US, TL? Fluorescent light, the tubes? Yeah. Okay, fluorescent. The thing is, if you shine on the blank directly, it's coming back in your face and you can see the very fine marks that you make. But this is actually an image of a key that's gone through the first round of impressioning, and you can actually see on the side of the blank 1, 2, 3, 4, 5 cuts. So that means that I can actually see all the pins were preventing the lock from turning when doing left and right, which is exceptional. Most of the time it's like 3 or 3 or 4. But in this case, we've seen all 5. And what you do with impressioning is, and this is by the way a microscopical view of what's going on, and I'm not sure how well you can see it, but that's really a clear mark, and most of the time that's not the case. But the mark that you see over there is typical from what a real impression mark looks like. And by the way, these images are from the book from Oliver Diedrichsen, the guy that taught me. I bought a few of these books with me, so if you're interested, I have only a few of them with me. So if you really want, we can talk. I can sell you the book. But what happens is that I see that the smooth pattern is disturbed. I see a dot, and where I see the dot, I file, and I have my round file. And where I see a mark, I will use my round file and cut it. Now, I can cut it in 2 different ways. I can use a caliper and know the steps, the increments. As we've seen from one of the first slides, it's all fixed distances. I can use the caliper to say, okay, this was a cut 0, we now go to cut 1, and do it as exactly as you can. Or you can say, I don't mind these exact numbers. If I see a heavy mark, I'll go deep. If I see a light mark, I'll take it slowly. And that's where the practice comes in. Once you learn how to read these marks, you know how deep to file. And if you see a mark, you file them away. If you don't see a mark, don't touch it. That's the basic protocol in impressioning. If you are looking with your little optics, and you think, is this a mark or is this no mark? Is this, you know, maybe pollution? Is this, what is this? Don't touch it. If you will file it away, the bottom pin will go below shear line and the top pin will start to bind. And then you lost. You can never go back up again. So you have to be careful, whatever you do, you know, don't file too deep, because then you lost forever. You cannot win the game of impressioning anymore. If in doubt, leave it, because once it, you know, if it's a 5-pin lock, if 4 pins are in a row, you know, the number 5 will scream with a very big mark saying, okay, here I am, you know, this is where you have to file. And if it stays that vague, is it the mark, is it no mark, leave it like it is. Another thing that you have to train with impressioning is don't use too much force. I mean, it's relatively easy to break the brass blanks. At the beginning, you know, I broke them like matchsticks. But now I hardly ever break them anymore. And that's because I've been practicing a lot. This is actually my first successful key. And I was really thrilled that after meeting with Oliver, I went home and I tried it. And my first try, it worked. As you can see, there's a little crack here on the shoulder side. So, you know, I was lucky that the key wasn't too deep. If the key has got a lot of 9s and 8s in it, it takes you much longer to do it. But for 12 months after my first successful key, and that is, you know, impressioning, I've been making at least 1 successful opening a day with this technique. Just because I think it's so much fun, it's so nice to be able to do it. And I studied the subject. It's not only that if I have a blank, I can open the lock. It also forced me to study, you know, what locks are out there. What is a popular lock in the Netherlands? What can you expect if you go to a door? Because nowadays, I assist a 24-hour lock service in opening doors if people lost their keys. And if it's in my area, they sometimes give me a call, you know, okay, this sounds like a very nice guy, you know, go help him out so we don't have to drill the lock or whatever. And I have with me 50 kilograms. I don't know how much it is in pounds, but 50, it's now, it's not 15, 1-5. Okay, it's 30 something pounds. With keys that have strings of 3 keys per profile that I'm about to expect. If it's not a popular profile, and 5 or 6 when it's a popular profile. Because, you know, if you spend 3 keys on a lock and you don't open it, it's at least 10 minutes per try. You know, that's the bare minimum. So if you haven't opened the lock after 30 minutes with impressioning, it's useless anyway. But, and I've been quite successful in this. The times that I open these locks in the field is between 10 minutes and 30 minutes. And the people are really happy, you know, that I'm able to help them doing that. You know, some eyebrows are being like, hey, you know, what's this guy doing? But if the door opens and, you know, nothing is damaged, then most of the time they're happy. Now the interesting thing is that this technique works on a wide range of locks. Oliver was one of the first people, I think, to find out, but maybe I'm wrong, but at least he's the one that taught me, that it also works on dimple keys. As we learned, you know, for instance, these Sargent Queso locks, they have pins from 3 sides. Normally, the holes are drilled in the key, but with impressioning, what you do is you just file over the whole length of the blank, because what you want is you want the key to go deeper. You do not care that it's not a nicely drilled hole. The key is in the way, and it just wants to go down. And there's only 1 row of pins per side, you know. So it's no problem to use a file and do it like that. And people look at you really funny if you have one of these keys with you, and they're used to seeing drills hold. And yeah, it's a really powerful technique that if you master it, you know, you can open a lot of locks with it, including lever locks, dimple locks, and it's really a fun challenge for me to do it. And I hardly ever practice picking anymore, because I'm really obsessed a little bit by this. So if you have blank keys, you know, any blank key, especially the high security profiles, you know, come talk to me. I'll trade you, or I'll work something out with you. Yeah, that's the presentation, and it went relatively fast. So we have quite some time for questions. Han, do you want to join?
I think maybe I can something about the special lock if they want.
What? Yeah, you want to?
RPS.
Okay, if you're interested, Han can do a small presentation about the special lock. That's the robotic key system. So I think that maybe that would be a good idea. Sorry? Let's say that we're asking questions until he's setting up his laptop. Can somebody assist him with setting up the laptop?
The last technique that you just showed.
Right.
The old school way of doing that was to also take a match and deposit some carbon on the key.
That's correct.
And that way you could see this a little easier. How does that compare to what you're doing here?
Right.
Is that really just impressioning too?
What you're saying is indeed that the old school locksmiths, and that's also the booklets that I read, they use a candle and what is it called? Carbine?
Carbon. So you get a black deposit.
The carbon that comes off of the flame is used to blacken the layer. On the other hand, Oliver found out that if you have a brass blank, the brass is much softer than the pins in the lock, and they will make an impressioning because, you know, the steel pin is bound, and you're going to push it up with something that's much softer. It will make a mark. So there's no need in using ink or carbon or whatever into that. And I know that in the books it says, you know, use a candle and do it, but he tried it for a long time, all these techniques, and he really studied it. I mean, you should read his book. It's really good. And it's not necessary if you have a brass blank.
Right, maybe the blanks weren't brass back then.
Yeah, maybe if it's steel, you know, it's much more difficult to mark. But thanks for the question.
Just to clarify, that the carbon technique was used with really old warded locks, where you had a steel blank and a steel lock, and you're trying to figure out where the lock is blocking the key from turning. Nowadays, if you try to use carbon or Sharpie magic marker or whatever, the pin force pushing down is enough to rub off the Sharpie, so you won't get any markings at all that are of use, because all pins will always mark.
I had a question about the magnetic keys.
Okay.
When you see the magnets inside, is the only thing that you have to worry about polarity? Is it either just plus or minus, or are there variations?
The nice thing with the magnetic key system from EVA, what you're talking about, is the round magnets, is that inside is a disc, and the disc is on a spindle, so it can freely rotate. If you insert the key, it will take this freely rotating disc, and it will position it in a specific way. And on one part of the disc, there's a little cut in the disc. And if all the discs are aligned, and I have with me a cutaway version of this system. So if you meet us downstairs at the Lockpick Village, I can show you the internals of that lock. And you know, it's a beautiful piece of art.
Great, thank you.
You're welcome. Eric.
Sorry.
Little Eric. Okay.
Have you tried modifying your high security?
In je PowerPoint even opladen. Dus
Waarom?
omdat ik hier ook wil lezen.
Okay, give you a second to
Kan
get your computer sorted out here.
Dat kan niet. It's not possible.
The USB plug goes into the USB port.
Yeah. I love you. I love you too, yes.
So have you tried modifying your high security key copies so that they will trigger the moving mechanism? Or have you tried using a pick or a paper clip or inserting magnets into them?
That's actually a really good question. I wanted to do that. I wanted to have in this presentation a key that was one of the keys that Hans said could not be done. And indeed, you know, where the moving element is, drill it away and make some paperclip touch above the line. But there simply was not enough time. But I'm convinced, and that's again what I say, you know, if it's about mechanical locks, they lose. It's, you know, if you want to make a mechanical piece of, if you want to make a piece of metal that will operate that lock, it will work.
Yeah, I was thinking of the motor with the magnet in the key. I have little magnets that would fit right there.
Yeah, so it's not a big deal.
When you were showing the silicon molding, I was wondering if that gave off any smell that might give you away when you're using that technique.
When I was first showing it to Han, he says, it feels like I'm in the dentist now.
Yeah. So
it does have a little smell, but it's not like in a chemical plant or anything. No.
Okay, thank you.
Yeah.
You said that the clay kit had a problem where the key that you made didn't last very long because it would wear away when you put it in the lock. There's a technique that you use for modeling where you use an epoxy. So you fill the mold with epoxy and then you fire it in the oven. And I think you might get something a little bit harder because I assume that's like lead or pewter or something. It's pretty soft.
Yeah, well, thanks for the advice. I will definitely look into that. I haven't heard about that, but it makes a lot of sense to use some epoxy and having it harden out. I just repeat the question because I'm not sure if, but I will look into that. What's the name of that?
I'm not sure if it has a name, but if you look up,
okay.
It's used for like making figurines and things.
Okay, thanks. I'll look that up. That's a familiar face coming up now.
There you go. All right. Well, first thing is coming what he just said. Actually, I got the impression, excuse the pun if you want to call it such, that you don't actually use the clay to open anything. You're making something with some other material. So I don't think I assume that would be, so the wear shouldn't be an issue. Actually, I was thinking about epoxy products myself as a possible way to make an actual key because some of them are quite strong. Now, different question. Okay, you're talking about a special silicone multi-part product, probably similar, like you said, with dental.
I have a very difficult time understanding you.
Okay, let me.
Can you make the question short and brief and compact and clear to me as possible?
More time here. Let me move back a little bit. That's too close. How's that? Any better? 1, 2, 3. Any better? Okay, my question was what this was. Okay, it's a fancy product using mixed epoxy, a silicone mix. My question is, what about normal RTV single part epoxy, silicone like you might use for other things such as caulking or other things? They're pretty rubbery as well and would probably still hold on an angle. Have you tried something like that? Because that would be a lot cheaper and probably be a lot simpler to work with if it would have the right characteristics, certainly more common. And it would be easy to do, just carry a little tube in your pocket. You wouldn't have to worry about mixing stuff or anything else.
You lost me.
Though. In other words, normal silicone in the tube, it's a one-part product. You don't mix anything. It's normal if you get in a normal hardware store. You might use to caulk your bathtub or whatever. It's still silicone. It's still very rubbery. It would still survive those angled cuts, I would think, if you get a good one.
Maybe. I don't know.
It might be worth trying. It's going to be a lot simpler. As far as the marking materials for impressioning, I never found with modern locks much luck with the soot method, but actually marker, if you use a good permanent marker on some locks can be helpful. I've read things that said it. I found, in fact, it can be useful sometimes, depending on the lock.
Okay.
I'm wondering what kind of metals you use for the clay molding.
Yeah, that's a good question. I bought these kits complete, and it's a relatively soft metal that will melt at very low temperatures, like with a candle.
So is it like lead, you think?
It's probably some compound with lead and zinc and.
Woods metal or
What's it called, Eric?
Woods metal or fields metal, right?
Okay, thanks, Eric.
Right.
Doug.
What are your views on the electronic authentication of keys from the locks? And would that add the extra layer of security? So even if you did copy the key with your methods that you talked about, then the key would still not open the lock.
Yeah. That's a good question, because I specifically said during my presentation mechanical locks, pieces of metal, mechanical. No, but you're right, because there's now a lot of electromechanical locks on the market, and they obviously, in theory, would not have these problems that you could copy them, because the challenge response cryptography in these chips is really strong in some cases. However, if people read my weblog a couple of weeks ago, there's people out there with very, very sophisticated, clever, simple techniques to bypass some of the electromechanical locks. And at this moment, as we speak, we're in close contact with one of the biggest manufacturers who have an electromechanical lock that can be bypassed with a simple ring with a few magnets, that if you twist the ring in the area, in the surface of this electromagnetic lock, it will unlock the electronic part, because we don't know exactly why that happens. It could be that the little motor that blocks the lock, by turning this magnetic field around, will actually remove the blocking element. Or it could also be that by inducing changing magnetic field, and if there's a coil anywhere on the path of that, of the unlocking mechanical or electronic element, current could be induced on that wire, and all of a sudden, things can happen. So it's nice to think that electronics is the answer, but I think that we're just at the very beginning of where this is going, and this is not anywhere near a solution that says, oh, if you use electronics, it's fixed forever. But it definitely is a good help. I definitely have to say that's the best defense you have at the moment. Thanks. Next.
Yeah, I kind of lost my voice here, so
okay.
Give me a little bit. I used to make small molds for car parts, and I would take like an old pager, like with the vibrate mode, and hold that up next to the molds as I was pouring metal in, and that vibrator would kind of take the bubbles out of the mold when I was pouring it. I don't know if you could use that with the key or not, but...
Yeah, that makes a lot of sense. Thanks. Did everybody get that? Because it was actually quite a good idea to use a little vibrating element on your key mold, and then if you insert the metal, the whole thing is already shaking. You have to be careful with your fingers though, because this hot metal is hot. But next.
I just had a question about my work key. I was under the impression it's the blue master lock key. That there were different combinations that you could set the lock itself to a different combination. Like mine's a green key. I think my boss has the red key. How would you go about finding which key would work with that particular lock, especially on one that was hard to copy like this one?
Well, there's been a whole discussion, I think maybe 4 years ago, by Matt Blaze and Mark Tobias, who found out a way to, if you know some keys in a master key system, or even if you know one, how to crack master key systems and how to calculate the master in a system, what that looks like. And most of the time, if you have access to one key of a master key system, and it is a general speaking, then the system is compromised, and you can open all the doors if you are determined enough to do the attack as Blaze and Tobias have laid out.
Even with the side pins, that because you need to find a blank, I guess.
Well,
no
that's what this talk was about making your own blanks and stuff. So the blank is not the problem. I mean, if you are determined enough, it's only a piece of metal with some grooves and some holes and some cuts in it. It's nothing more, nothing less. And it takes determination, especially with the multi-lock interactive lock that you have there.
Right.
I don't say it's easy, but on the other hand, if you would give that key to me for 20 minutes, or no, for 20 seconds, I make a detailed photocopy of it, and I give you a week later, I give you your key when I'm back in the Netherlands, and I just read how deep it is and what the combination is. And most likely, I mean, I cannot say it with 100% certainty, but with a high degree of certainty, I can make that key for you without seeing that ever again.
Oh, okay.
Mr. Schuyler.
Hey, Barry. I was wondering, do lock companies implement things in the lock, such as particular pins, anything like that, to specifically thwart impressioning?
Yes, there are some pins. For instance, Dome makes a pin that is a bottom mushroom pin. All the mushroom pins are top pins normally. And with picking, that's very frustrating, because then you pick and you have the idea, aha, the lock is turning, but actually the mushroom pin is in the way. And Dome makes these pins bottom pins. With impressioning, you never have problems with mushrooms. As a matter of fact, if your lock turns like it's in a mushroom, it's an indication, okay, dude, you went too deep, because now you have reached a pin that's normally on top of the bottom pins.
Here's a picture of that, Barry. If you want, I can show.
No, it's okay. I think it's clear enough, I think. So that's with impressioning and key specifically, or pin specifically for that purpose. So, And I've also seen them in French lock. I think Fachette also has them. So, yeah. Good. Wat moet je nou toch, man?
Niks, jongen, niks.
Next.
Hi. I've been noticing that a lot of the European keys are actually a little bit more secure than the ones in the United States, just by your presentation, for example. I'm wondering, how easy is it to import European locks into the United States, meaning like buy one from Europe and get it mailed to me in the United States?
Well, you should talk to Han about that. Han is an expert on that field. He also can maybe deliver some US-shaped high-security locks. Yes. And after the presentation, just meet up with him downstairs at Lockpick Village, and it will work out.
All right, thank you.
That's fine.
Yeah?
Okay.
Okay.
Can you switch this on? No, in your laptop.
Why?
Because I like that. Okay, can I sit here? My English is not that good as from Barry. I first will go to the correct sheet. Okay. Oh, this is a sheet I found now. It's a sheet which demonstrates the floating part in a key for the protection against molding. I don't know if people are interested, if they want to know how that works. Yes? Okay. Now we all can imagine this is a DOMI X system, and there is a floating part in the element, a floating element in the key. On the left side, you see the key with the blue ball bearing. On the right side, at arrow A, you can see an extra chamber where a red pin and a red top and bottom pin are mounted in. If the spring pushes down here, pushes down the top pin, and the rotation is blocked. If I insert the correct key, there is a blue ball bearing. That blue ball bearing lifts up the bottom pin, and we have a shear line. This is clear? Okay. The trick is that the ball bearing has a certain diameter, so that you have the correct height to create a shear line. If you look on the left picture, or the picture in the middle, you see a blue pin in the plug. Yeah, we see that? This plug is stuck. It's a fixed plug. This plug prevents that if you insert a key which is not milled deep enough, does not go in the hallway. You understand? And on the tip of the key, there is partially the key is milled in deeper. And because the key is milled in deeper, it can go under the blue pin here. So everybody understands, so that now you can insert the key, and but if you insert the key, wait, I will point it out as if you insert the key, the flash of the key is this height. This height. I assume you all understand that. And because the height is not deep enough, this red pin rests below. Yeah? And because that pin rests below, there is no shear line. And therefore it does not rotate. And the most clever trick is then the ball bearing. The ball bearing has the right height. But how do you get that right height on the right position if there is a fixed pin? You understand? And therefore, they made a tunnel in the plug. So that the ball bearing could go under it, come at the correct position, and lift the red pin. Is this clear to all? Okay, this is an example of a floating element in a key. This is an example Barry showed before, this easy entry picture. And the easy entry is a milling machine, and it measures the profile of a key. So it scans the key here, and it puts it somewhere in the software, and then a mill is activated, and it makes a copy of the key here. It mills those tracks on the key so that the key will fit in a lock. And we visit the company Gege. Gege is a big company, and there you have the next keyway on the left side, and you can see in the circle an undercut. Yeah, it's a part in the keyway which sticks out. If you look straight on the key, you can see that the key looks like this. That's an original key. If you then scan the key with the easy entry, you scan the key like this. Yeah, but if you scan the key, you don't scan the hollow part in the key. Yeah, that part does the machine not see. Is that clear? And because the machine does not see that part, he just makes a key like this. So the black part is solid. Yeah? Does this key fit in the plug, yes or no? No, okay. So there were clever guys who said, if he does not scan the dark part here, I file the whole part away, and then I get this key. Correct or not? Yeah. Does this key fit in the keyway? Okay, now this key fits in the keyway. Correct. But Gege was clever, and they did not like that. No, because otherwise now people could copy their key. And we see on the left, we see the original key, and we see the undercut. In the middle, we see the key made with the easy entry. Yeah? And on the right side, we see the key where we have filed away this part. We all see that? And Gege was that clever that they inserted an extra slider in the lock, and we can see that on the left picture. That slider is blocked by going further because of this part in the key. You see? On the left picture you can see it. You see the red slider? It cannot move to the left side. Yeah? If I now have an easy entry key, which is faked, and I milled this away, the slider goes in. Do we all see that? And then the rotation of the key will be blocked after 90 degrees. Okay? This was just in short. What? What do you say?
Can you defeat that some other way?
We didn't. We didn't find a way till now. Yeah, okay, keep it in the middle. You know, shall we make the questions later? Okay? I show you in short some experience we've had about bump keys. Oh, this is the pin Skylar referred to. This is an example of an Domi X. And I think it's, yeah, you cannot see the details of the pins, so let it be. Oh, and here is where I wanted to start my talk. I have the screen. Wait a moment. Ik zoek mijn muis. Yeah, okay, easy. Now, I now want to tell something about the RKS lock. And RKS stands for Robotic Key System. This RKS system is developed by Stanton Concepts. It's an inventor who lives in Stanton, nearby New York. And it's the world's first open source locking system. And I am then referring to the key. The key is motorized, as you can see there. And therefore we call it also a robotic key. And the cylinder is purely mechanical, which is on the left. With this robotic dialer, you can rotate the discs in the cylinder so that the cylinder goes open. This lock was first presented in Snake in 2005. Yearly we have with Tool a big event in the Netherlands, that's a Dutch Open. During that event, people from France, Germany, United States, United Kingdom and the Netherlands come then. A lot of lock pickers and a lot lock enthusiasts. And the inventor demonstrated there his lock. That was in 2005, and people could play with the lock. They could give comments on the lock. They could try to manipulate the lock. And the inventor went home with a lot of good ideas. And he was clever enough to implement these improvements to get a better lock, so that it was more covered entry secured. Okay. The most strongest point about this lock is that there is no hole on the inside. You can see you can see this part. On this gray part comes the dialer. That's the tip of the dialer. And if that dialer is placed on the cylinder, it starts rotating. And just like a combination lock of a safe, or just like an Abloy Protec, the discs start rotating, and one by one they get in the correct position so that the locking bar can drop in. Yeah, it's a very special mechanism. Now, these are some overthoughts the inventor had. He developed this lock in first instance for the container transports, because he said there were some problems with the containers. There were cases of key lost, etc. And you can imagine if you have a container and you ship this from China to the United States, how do you then handle with the customs en route? Because as we all know, the customs has the authority to to inspect the container between China and America. And the point was, you could put a lock on it, a padlock, and then you could put the key from the padlock with that container, and then somebody could open the container with the lock, remove stuff from it, and close the container again, and place the key back. So that was not a solution, because it could not be tracked that the container was opened. And if you put a lock on that container, and you send the key to China or to the US, and the customs would check that container, they had to cut open the lock. So that was also not a solution, and therefore they came with seals. A very clever solution, but if you use these seals, after use, they are, you can throw them away, and they are not trackable. They are hard to track. And these were reasons to invent the RKS system. These are the parts in the cylinder. I will go, there is less to say about this. I think this picture is clear. And these are the parts in the cylinder in detail. I want to show how the cylinder works if I get this on. Okay. Here. Here I have the cylinder in my hand. It's incredible. Here I have the cylinder in my hand, and the first thing what we can see are the discs and a locking bar in it. This is the front of the cylinder, and this is what we call a manual dialer. This manual dialer is exactly a dialer from a safe. We can place this dialer on the RKS cylinder. And if we rotate the dial, we can see that the discs start rotating. I think most of us are familiar with combination safe locks. Yes? Now, if you have a combination safe lock, you normally count till 3 or till 4, and then you have had all the discs. And curious if somebody's, how many discs are in the lock? Some people who think, how many? 5? I thought there were 6. Okay, now, I rotate this lock, and you can imagine the last disc, so the discs, the disc on the right, the disc in the front of the lock, will be positioned first. So, and I rotate now further, and you can see the chamber or the gate. I rotate it, it's a little bit stuck. The first disc is now aligned. Can everybody see that? Okay, now that means that we now make 5 or 6 rotations back, and then the next disc will also be aligned. Everybody see that? Is it sharp enough?
Almost. You can kind of see it.
What? You see it? Okay. Now we rotate to the right, and this way we can open the lock. Is this handy or not? Yes. Is it secure or not? Yes, it's secure. Because if you can manipulate, it's hard to manipulate a 7 or a 6 disc safe lock. It's already hard to manipulate a safe lock with 3 discs. Yeah? So this is a very secure lock. But the point with this is that the manual dialer is not handy, because it takes a time to rotate the combination, and therefore the inventor came with this thing, and that's what he called the robotic dialer. And I now will insert a robotic dialer on the lock, and then we will see what happens. Oh. Okay.
Away from you. To the top of the screen.
To the top of the screen. Wait a moment. How do I do that? Oh. Okay. Now, I do it again, and we can see that the locking bar goes in. And this is one of the nice things about the robotic key system, because normally you use the dialer to open the lock, yeah? But if you don't have a robotic dialer and you only have the manual dialer, it's possible that you get a combination from somebody and that you can rotate it by hand. Here, I now dial the combination fully away, so it's now fully blocked. The cylinder does not rotate. You see it? It blocks. It's stuck. It's stuck. I push in the knob of the robotic dialer. We see the key, the disc rotate. And the lock is open. Yeah? Point with this system is that the dialing instructions can come in by GSM or by GPS, etc. So this is the way customs can open that lock on the way. Yeah, there is a lot to tell about. There is a lot to tell about how the lock exactly works, because I only showed how to open it. And I think I can invite everybody to the Lockpick Village. There we have John Laughlin. John Laughlin is one of the inventors of this system. He has some stuff with him so that everybody can play with it, just like in Snake. And maybe there are people who have find a weak spot or whatever. Wait, wat zei je, buddy? Okay, now this was, are there questions about? Or are there questions now? Then go to the mic.
How do standard combination lock techniques apply to opening these types of locks? For example,
that is an extremely good question. And I have an extremely good answer. No. Can I get the... As we all know, everybody who has dialed a combination lock knows he rotates 3 times right, 2 times left, 1 times right, 1 times left, and the lock is open. Yeah, that's the standard rotation of a combination lock. And therefore in the market we have dialers. Those dialers are automatic devices which you can mount on a safe, and you let it 3-4 days rotate and it dials exactly all the combinations with all the possible combinations, yeah? And this is a way to manipulate locks. If we look at the discs of this lock, we see 8 holes here. 1, 2. Yeah, there are 8 holes. In these 8 holes, you can mount a screw. And you can see the screws here. These screws have the function of the fly. And the fly in a combination lock is a part which sticks out on the disc. If I now rotate the first disc long enough, then the screw comes at another screw or another fly. He grabs the second disc and the second disc starts also rotating. Now that second disc starts rotating, it's grabbed by a next fly, as you can see here, and at a certain moment all the 5 or 6 discs are rotating. Because you can vary the position of the fly, because you can put the fly on 8 different positions, you also get a different rotation pattern. Yeah, so the rotation pattern is not 5 times left, 4 times right, 3 times left, 2 times right. Because of the changing of the fly positions, it's a very strange experience which I had when I dialed it, because you have, for example, dialed 4 times to the right and then take a number, and then 4 times to the left and dial a number, while it is normally 4 times to the right and 3 times and then 2 times and then 1 times. Yeah? But I advise everybody to come to the Lockpick Village and then you can see it yourself. Yeah? Other questions?
Is there a date set when these will be available for purchase?
Can you repeat that, Doug?
Available for purchase. Purchase.
You can buy. Now, the inventor has made 100 of these locks for test purpose, etc. And he also has the cutaway version with the manual dialer. And I thought for $125 you can buy the lock, and for $50 you can buy the dialer. And he has only made 100. They are all numbered uniquely. And I think they are collector's items. And they also, now beside the fact that they are collector items, they're also nice gadgets and nice toys for the boys. So really come to the Lockpick Village, see the lock yourself, and I think he has brought 10 of these locks with him, and that's it.
Okay, then I'd like to point out that as with every year for the conference, we have made a special pick set design that's specifically designed for this conference. And since it's the last hope, we decided to make something when, you know, when it's the last thing that you might have to let you into your own house or to assist other people. It's a credit card sized pick set where you can break away the parts if you really need them. I'm going to leave this one intact. And yeah, they're also for sale here on the conference. And it's a very nice design because the corners of the pick set are also tensioners. So if you break it out, there's an 11-piece pick set left for you. So it might be fun to pick one up at the points. Okay, then when I'm doing sales here, I might as well talk about Mark's book on Medeco. It also covers quite a deal on key control, duplicating keys, you know, making copies of keys that they don't want you to make copies of. So that might also be a good investment if you're into locks. I think this is it. Thanks a lot, and hope to see you at the next hope.
Coming up next in this room, for those of you that have ever traveled and got one of those really nice notices that your bag has been rifled through by the TSA, there's a gentleman who put a camera inside his bag and filmed what the TSA did with his bag. So that's a bag cam. How did the TSA and the airlines manage to do that to your luggage? That'll be in here in just a minute.